Hi, welcome to the video on interpreting the results of linear regression model. By the end of this video, you will be able to interpret the results of your linear regression model. Let's continue our discussion on implementing linear regression. In the previous video, we verified the assumptions of linear regression. We will now look over the magnitude of the coefficients using a bar graph. This will help in interpreting the linear regression model. We first make a data frame called the coefficients underscore table, in which we store the column names present in the X train and the coefficient allotted to each and every one of those columns using the lr.coef. Next, we sort the data frame based on the coefficient values this way. It will be easier to observe each and every coefficient. For this, we will define x as the name of the independent variables and y as the coefficients calculated for those independent variables. Now we visualize this using a horizontal bar graph. We pass the list of columns and corresponding coefficients calculated by the model. Now let's run this cell and see the coefficients. In this plot, we can clearly see all the coefficients arranged in descending order, which makes it very convenient for us to examine them. There are a lot of inferences that we can draw out from this plot. Let's move from top to bottom. We can clearly see that the zip code underscore groups have come out to be the most significant in this model. Interestingly, it is very much aligned to the natural intuition that location plays a major role in the sale price of the house. Other than the zip code groups, area of house from basement has played a major role, which again is in favor of the natural intuition. Similarly, overall grade has also played quite significant role. Age of the house is somewhat a counterintuitive. Often it is rational to think that older houses might be less expensive, but our model says that older houses are actually more expensive than the newer ones. This is new knowledge. Some other independent variables like number of bathrooms, lot area, number of times visited, basement area, condition of house excellent, waterfront view have also played a significant positive role. Coming to the features with the negative significance. Years since renovation has received quite a bit of negative significance. This tells us that as the time from the last renovation of the house increased, the price of the house decreased. Or in other words, customers often prefer the houses that are recently renovated. The most interesting inference is the role played by the longitude and the latitude. We can infer from the plot that longitude has significant negative significance and latitude, on the other hand, the significant positive significance. So what does this tell us? This data is about the houses of North America, and if we interpret the geographical results that we have obtained from the linear regression, the houses in the northeast region have relatively higher prices than other places. This is some information which we were not able to extract early on. New information like this is where the essence of the data-driven decisions lie in. I believe that you will be able to draw out the inferences further. You have now understood how the linear regression model is implemented using the sklearn library and understood how we verify the assumptions of the linear regression and interpret the final model. Wow, that was a lot of learning we did in this topic. Congratulations and well done. With this, we come to an end of the fifth topic of this module. We are nearly done with this module, and in the next and final topic of this module, we will learn about feature engineering. Stay tuned.